We're going to do a problem here that's kind of interesting. I looked in the book and I found, whoops, let me get my marker going here. Maybe. There we go. And I looked up orbital periods and orbital radius of Mercury all the way through Saturn. And I wrote those down in this table. And the question is, can I use this data somehow to find the mass of the sun? And so if you look in your book, or I don't know if it's on the equation sheet for sure or not, but if you look, it's part of Kepler's law. T squared equals, and there's r cubed over here, and then there's this thing in the middle that's 4 pi squared big G over M. And so really what we would be looking for in this is this, oops, this right here. That would be the mass of the sun. And so the question is, can we find a way to graph this on here to get a straight line, and the slope would somehow give us the mass of the sun? Well, if you look at it, the y variable is t squared, so what I could do is I could graph t squared over here. R cubed is the x, so I could put r cubed here. And if these are good numbers, I should get a straight line, right? Should be a straight line. And the slope should equal all that in there. And all I have to do is solve for m, because 4 is a number, pi squared is a number, g is a constant, m is unknown, and I get the slope from the graph. So, and here's what I did. I did all this in my calculator. You can do most of it in your calculator. The orbital periods, those are going to be the y. The orbital radius is going to be the x. And so what I'm going to do is in L1, I'm going to put these orbital radii. In L2 of my calculator, I'm going to put the orbital periods. So once I get all of them in, I'm going to go in, I'm going to highlight L1, so highlight L1, and then I'm going to cube, math 3, all of those, all of the radii. All of those, I'm going to cube them. So this is going to be r cubed, which is meters cubed. This is going to be t squared, which is seconds squared. And these are all seconds. This is all meters. So if you put it in your calculator and just do and highlight L1, and then do second number 1, which puts an L1 in the part down at the bottom, then once you do that, you'll do math 3, and it'll be L1 cubed, and you'll push a button, and you'll get numbers like this. This is numbers I got. 1.9 e to the 32nd, 1.3 e to the 33rd. Let me write down all these numbers. 33rd, 34, 33rd, 34, 35, 36, E, and then I got 1.2, 4.7, oh, I missed one here, I messed up. This one's actually 3.3. This is 3.3. this is 4.7, so this was messed up. This one is 1.2. Should be the decimal right there. And this one is 2.9. Then I'm going to square all my periods and put them in here, and I get these kind of numbers. E13, e to the 14th. They're all big numbers. E to the 15th, e to the 15th, e to the 17th, and e to the 17th. 5.8, 1.1, 1.5, 2.3, 7.8, and 1.4. So your calculator will do all this for you really quickly. And then I go ahead and I be sure my stat plots are on. They're on. L1 is X, L2 is Y. And I just put zoom number 9, and that gives me some dots. It gives me a whole bunch of dots down here that I can't see very well. Then it gives me one dot here I can see really well, and one dot here. Now, if I go stat calc and I go to number 4 linear regression and I hit vars, go to y vars, function, y1, I'll get in my, I'll second quick, get out of the graph. I'll have on my calculator screen linear regression, ax plus b, y1. Press enter, and that gives me a slope of, here's my slope, 2.969, so 2.97, 2.97 e to the negative 19th. And that's a really small number. And so what I'm going to do is I'm going to set that number equal to, so I'm going to go down here, I'm going to set that number equal to all the stuff in the middle. So basically if I solve for m, I'm going to get m equals 4 pi squared over 6.67 e to the negative 11th times the 2.97 e to the negative 19th. And when I put that in my calculator, I get the mass of the sun equal to, hold on a minute and I'll tell you, 1.99. So m of the sun should equal 1.99 e to the 30th. And if I look that up in the book, let's look in the back here. I don't see it in that book. I'm pretty sure it's correct, though. Let me look at this book. All right, nobody believes in the sun anymore. I don't see it. Well, I'm pretty sure I looked it up in your book, and oh, here's mass of the sun, 1.99 times 10 to the 30th. There we go. That's kilograms. So there you go. That's the way to do a problem like that. And that comes from this equation. You might want to check and be sure that's on your equation sheet. I don't remember how many of those, if any of them are on your equation sheet at all. And we'll stop there.